Class 11th Chemistry, Unit 7 Equilibrium, and in this video we will discuss about buffer solution. First, what are buffer solutions? The solutions which resist change in pH on dilution or with the addition of small amounts of acid or alkali are called buffer solutions. These are of two types, acidic buffer solution and basic buffer solution. First come to acidic buffer solution. This is made up of weak acid and its salt formed with this strong base. For example, solution formed by acetic acid and sodium acetate. Its pH is 4.75. Acetic acid is a weak acid and sodium acetate is the salt of acetic acid with this sodium hydroxide, which is a strong base. Okay, so we can say sodium acetate is the salt which is made up of strong base and weak acid. Basic buffer solution. This is made up of weak base and its salt formed with strong acid. For example, solution formed by ammonium hydroxide and ammonium chloride and its pH is 9.25. Ammonium hydroxide is a weak base. And this ammonium chloride, this is the salt of ammonium hydroxide with hydrochloric acid, which is a strong acid. Okay. Now, designing buffer solution. How can we prepare the buffer solution? Knowledge of pKa, pKb and equilibrium constant helps us to prepare the buffer solution of known pH. First of all, we will discuss about preparation of acidic buffer. To prepare a buffer of acidic pH, we use weak acid and its salt formed with strong base. Now, we will consider the equilibrium of weak acid, Ha. Ha, when dissolved in the water, this will form H3O plus plus A minus. Okay, this Ha, this is the acid. And when it lose proton, then this will convert into A minus. So we can say this A minus, this is its conjugate base. Clear? So we can write Ka, acid dissociation constant, is equal to concentration of hydronium ion multiplied by concentration of conjugate base divided by concentration of acid. Now, taking logarithm on both the sides, we will get this one. Log Ka is equal to log of hydronium ion plus log of this ratio. Now, this is the concentration of conjugate base and H is the concentration of acid. Now, multiply each term by minus. So, we will get minus log Ka is equal to minus log of hydronium ion concentration minus log of concentration of conjugate base divided by concentration of acid. Now in this minus log Ka, this is equal to pKa, and this minus log of hydronium ion concentration, this is pH. So we can write pKa is equal to pH minus log of, this is the concentration of conjugate base and this is concentration of acid. Now if we rearrange this equation, then we will get this one. pH is equal to pKa plus again log of concentration of A minus divided by concentration of Ha. Where what is this A minus? A minus is a conjugate base. So you can also write this pH is equal to pKa plus log of this ratio. Okay. In this case, we are including concentration of conjugate base to concentration of acid. And this expression or this equation is known as Henderson-Hasselbalch equation. Okay. Now, in this equation, this conjugate base is mainly due to salt. Okay. Mainly due to salt because we are taking the weak acid. And weak acid means partially ionized, and when we are adding a salt which is having one ion common, due to the common ion effect, the concentration of conjugate base obtained from the weak acid is again negligible. Okay, so we can say this conjugate base is due to mainly the salt. So this can also be written as pH is equal to pKa plus log of concentration of salt to concentration of acid. Now in this expression, if concentration of salt and concentration of acid is same, then pH of the buffer solution equal to pKa value of weak acid. For example, for acetic acid, pKa value is 4.76. Therefore, pH of the buffer solution formed by acetic acid and sodium acetate taken in equal molar concentration will be around 4.76. Now, in the same way, we can also prepare the basic buffer. To prepare a buffer of basic pH, we use weak base and its salt formed with strong acid. For example, this is the equilibrium equation for weak base B plus H2O converting into BH plus OH minus. Now again, in this is a weak base. Okay, and when it's accept the proton, then this will convert into BH plus. So we can say this BH plus is its conjugate acid. Clear? Now for this expression, we can write the for this equation we can write the Kb, base dissociation constant. Kb is equal to concentration of conjugate acid multiplied by concentration of hydroxyl ion divided by concentration of base. Now again, taking negative log on both the sides, then we will get this one from this to this. Minus log Kb is equal to minus log of hydroxyl ion concentration minus log of this concentration of these ratio of these concentrations. Okay, now in this expression this minus log Kb is equal to pKb and minus log of hydroxyl ion concentration is POH. So we can write pKb is equal to POH minus log of concentration of conjugate acid to concentration of base. Now again, if we rearrange this equation, then we will get this one. POH is equal to pKb plus log of. Now we can say this is a conjugate base. So we can write this concentration of conjugate base BH plus to concentration of base B. This equation is known as Henderson Hasselbalch equation. Okay. Now again, this conjugate acid is obtained from the ionization of weak base. And again, we are also taking the salt formed with the strong base. So we can say this weak base and salt which we are adding, they have the one ion common. And due to common ion effect, the ionization of weak base is very less. So the conjugate acid obtained from the weak base is negligible. So we can say this conjugate acid is due to ionization of salt. So we can also write this POH is equal to pKb plus log of concentration of salt to concentration of base. Now if you know the POH, we can find out pH using this relation. pH plus POH is equal to 14. If we know this one, we can calculate this. Now pH of the buffer solution is not affected by dilution. Remember it. If we dilute the solution, we are diluting the concentration of salt as well as concentration of weak acid or weak base. So the ratio under the logarithm term remains unchanged. Okay. Thank you. Subscribe my channel to get the next video from this chapter.